Hello, my name is Dr Adetunmise Dada, and I'm a researcher in the School of Physics and Astronomy within the Glasgow Optics Group. And my research really focuses on optical quantum technologies, and that includes both quantum communications and quantum optics. Quantum technologies refer to technologies that harness the power of quantum physics to deliver real-world applications. And one very good example is communications. So normally when you want to secure your communication, you use what's called a cryptographic key, a small password that is shared between you, the sender, and the receiver. But it turns out that the security behind the classical way of doing that is limited. Quantum communications brings in that layer of hacker-proof security in the sense that when you distribute the keys using quantum optics, using, for example, photons, your information is unconditionally secure. In future, global communications will depend on satellite transmission. And in fact, it's very much the case today. But the problem of security is still there in the sense that you have, for example, a satellite sending messages to Earth and maybe relaying message between 2 points on the globe. The only way to do that securely is using quantum optics. The project that I've worked on explores the fact that such systems are able to do so only at night time. And that's because during the daytime, the background radiation from the sun is just so much that it overwhelms the signal. The solution we kind of came up with is to use a part of the electromagnetic spectrum where you have a simultaneous existence of low solar background and high transmission through the atmosphere. The next step was then to develop a quantum light source which emits at that wavelength. The idea with the project that IAA funded is that we want to take that source and redesign it and get it to a stage where you can actually use this to do quantum key distribution, which is the scheme or protocol which allows you to do that secure key exchange. And IAA was really instrumental in allowing us to do that. The team's very helpful. They worked with me right from the early stages of developing the proposal to actually following through on the different sort of avenues of impact that we're able to achieve. The project is at a stage where we are now in full collaboration with partners, and one of the channels we're currently testing is transmission through fiber. The IAA really helped to develop collaborations, proposals, and that led to proposal applications jointly with BT to follow up on the IAA project. And also currently there is still ongoing talks with BT on developing something together. So that's been a great outcome of the IAA project.